Alright, welcome everybody. So sorry that this is coming to you so late, but today I'm going to talk to you about alcohols and some of their reactions. It's going to be a quick video because it's going to talk about the few reactions that you need to know for alcohols. One of the things that you need to understand is that alcohols are combustible. You might already know this. And another thing is how alcohols are oxidized. And so we're going to look at both of these types of reactions in the next few slides. So because alcohols are combustible, they're readily used as fuels. In fact, you might notice that when you go to the gas station that sometimes it says that the fuel contains up to 15% ethanol or 10% ethanol. That ethanol is an alcohol with two carbons, and that is what is used as an additive to the fuel. And so they've been doing this for a long time now. Methanol can also be used for things like, competitive motorsports and even monster trucks. Some of the ethanol is taken from fermenting the certain crops. And this is really controversial because you're taking the foodstuffs that normally would be used for people to eat, and now you're using it to make fuel. And there's been a lot of controversy and issues with that whole concept. So we'll also talk about oxidation of alcohols. And this is really, like you have to sort of be able to identify what is actually doing the oxidation, so the oxidizing agent. And it's normally some type of chromate or dichromate. And so what happens is you have the chromate or dichromate being reduced from its +6 state to its +3 state, and then you have the alcohol being oxidized. And so they'll have this represented as an O with a bracket around it. So you'll have an O with a bracket around it, and that is showing you the oxidizer or the reducing agent, or oxidizing agent, sorry. So let's go through some of these reactions here that you need to know. So this is showing you a primary alcohol on the left here. This primary alcohol has the OH attached at the end of the carbon chain. Now, if I oxidize this, if I add that dichromate reagent to it, that alcohol will lose a hydrogen and a double bond will be formed, and you will oxidize the alcohol to an aldehyde. Now, if you continue to do this and you oxidize it further and heat it, then you'll add more oxygen to it. And something that's interesting about oxidation in general, when we talk about it in regards to organic chemistry, you go and you ask an organic chemist, hey, what does it mean to oxidize something? And a lot of times what they'll say to you is, it means to add oxygen or to remove hydrogen. And that's what we're doing here. We're adding oxygen or removing hydrogen. So this is a primary alcohol. Primary alcohol can go all the way to a carboxylic acid. You could add up to 2 oxygens, or remove more hydrogen, form more bonds, and have a total of 2 oxygens. But if you have a secondary alcohol, what I show in the next part here, you can oxidize this alcohol group to a ketone with its carbonyl group, but then you can't oxidize it further. And so it'll oxidize once, but you won't get that second oxidation. And if you have a tertiary alcohol, well then when you try and oxidize it, you won't get any reaction. So that's really all there is to know about the oxidation of alcohols and the reactivity. So alcohols will combust, and remember, when we combust them, you'll have an alcohol like C2, just switch to my pen tool here, C2H5OH, and you'll combust it, you'll add O2, you'll form CO2 and H2O. If you have a primary alcohol, it will oxidize to an aldehyde, and then it can further oxidize to a carboxylic acid. If you have a secondary alcohol, it'll oxidize to a ketone, but it won't oxidize further than that. And if you have a tertiary alcohol, there won't be any oxidation occurring. Now I want to just quickly introduce the idea of of the halogenylalkanes and how they react. These are called substitution reactions, and what we'll do with them is I'll show you how you can react a halide, halogenoalkane, with a strong base such as sodium hydroxide. And these are substitution reactions. They're given two names here. We have Sn1, just highlight that. We have Sn1 for the nucleophilic attack substitution one step, and then unimolecular, and then we have the Sn2, which is the nucleophilic substitution, where you have two molecules reacting at once. So what I'm going to do is I'm going to show you a little bit about these nucleophilic substitutions. So this is one of the reactions that's really studied a lot in your first semester of organic chemistry in college. The idea of a nucleophile is something that is nucleus loving, or that is really attracted to a nucleus. So the nucleophile itself has a very negative charge to it. That negative charge will be attracted very highly to the positive charge of whatever it's attacking. Water, hydroxides, OH minus, H2O, those are both really good nucleophiles. And what you're going to see is that there's going to be this partial positive charge that is going to be assigned to the carbon atom of the organic compound, and the nucleophile is going to be attracted to that partial positive charge of the carbon, and it is going to react with it. So this is showing you the overall reaction of a halide and a strong base. So here is my halide, here is my OH minus. The OH minus will come in, it will attack and replace where that bromine was, and you'll produce an alcohol and a salt. And here we have our halide. The OH will come in, it will replace that, you'll have an alcohol and a salt. Now the conditions are using an aqueous base and gently warming it so that the reaction will occur quicker. Now let's look at what the mechanism is that's happening here. The first mechanism, and this is not going to be on your IB test that actually took it out, it used to be part of it, is called an Sn1 reaction. I still think it's worth doing. I think it's interesting to give you a little taste of organic chemistry here. So this is Sn1, stands for Nucleophilic Substitution Unimolecular. And that means that all the action happens with one molecule at a time. And so they show the first step. So the first step is to have the bromine leave. And they actually call this a leaving group. So the bromine will leave, and what you'll be left with is a positive carbon atom as a result. Notice the electrons are going with the bromine. The bromine is more electronegative. What you're then left with is this positive carbon atom called a carbocation, and the OH minus from the base will come in and it will be attracted to that. This is my nucleophile. My nucleophile will then bond to that and we'll end up with our alcohol here. Now notice that I'm drawing a carbon that has 3 carbons attached to it. This is a tertiary halide. Those are the ones where the Sn1 reactions happen. There's another type of reaction where you will have Sn2, where you have 2 molecules at once. And what you can see is that while the Br minus, or while the Br is leaving and forming Br minus, the OH is coming in and attacking at the same time. And so you'll end up with this intermediate here, this transition state, where the Br and the OH are partially bonded, and then the Br will leave. So in this case, Sn2 stands for nucleophilic substitution, bimolecular, meaning both the OH and the Br are both attached to that carbon at the same time, and you have two molecules or two particles reacting and involved in the slow step of the reaction. So there's some information down here, but it's not the most important thing for you to know. I just wanted to show you the mechanisms. You won't be tested on this on the IB exam. I do expect you for our test to have some idea of the difference between Sn1 and Sn2. But mainly what I'd like you to know about is that the Sn1 occurs when you have one of these tertiary carbons. The Br leaves first, the OH comes in. With the Sn2, as the Br is leaving, the OH is also attaching itself, and you get this transition state. You don't have to worry about a rate law yet. We're going to do that later on. So here's just a quick summary. You know, if you have Sn1, then you have, if you have a primary halide, then it's going to undergo that Sn2 reaction that we just saw. If you have a secondary halide, you're going to have a mix between an Sn1 and an Sn2, but the reaction will result in the same product. If you have a tertiary, you'll have that first type of mechanism that I showed you where you'll have the Sn1. You don't need to know why this is the case, but you know it has to do mainly with the stability of the carbocation. Okay, so this is giving you sort of just an overview. This is a good study page to look at. One last thing I want to talk to you about is esterification reactions. So we've done this in class. We made esters, and you need to know the mechanism. Not the mechanism, just the overall reaction. An organic acid with the COOH group and an R here will react with an alcohol that has its OH. You will lose water in the reaction, and then what you will get is you will get your R from your alcohol, and then from your original carboxylic acid you'll get R, and then C, O and O like this. And so this is my overall reaction, and then the water comes out as a result. So I would definitely know, esterification. If we needed to add a few drops of that sulfuric acid, and that sulfuric acid was mainly to sort of pull the water that was released out away from the end product and sequester it. Alright, so this is organic chemistry. I hope that you learned something new for this chapter. We'll go over this tomorrow in class, we'll review, and then your test will be in a few days. Alright, thanks so much for watching.